Greetings, ladies and gentlemen. This is Freddie Matanzela and welcome back to my YouTube channel. In today's video, we'll be looking at integrating using U-substitution. But first, let's start. Let's say you have an integral 1 over x plus 3. So you are required to integrate. Since you see something like this, you can apply the law that says an integral f prime at x over f at x is equals to ln f at x plus c. So therefore, now we will do what? We will choose our f at x. So let f at x to be equals to x plus 3. And our f prime at x will be equals to f prime at x will be equals to 1. So therefore, with this information, if you see our original expression already follows this rule. So if it follows this rule, so we can apply it and say the integral 1 over x plus 3 is equals to ln x plus 3 plus c, because of it follows the rule, because this follows this rule. So now let's look at if we are having something like this now. Okay, let's say now I'm having something like this. Let's say I'm having an integral x over x plus 1 all in squared dx. So therefore, we'll also follow the rule that says an integral f at f prime x over f at x is equals to ln f at x plus c. So now let's choose our f at x. So saying that our f at x will be equals to x plus 1. So that means our f prime at x will be equals to 1. So therefore, if you check, our information here doesn't match this rule. They don't match this rule. So therefore, since they don't match this rule, so that means we can't do it like that. But now, how can you fix it? So we can fix it by using U-substitution. So I'm gonna write with a different pen. So let me rewrite it again. Let's say now I'm having an integral x over x plus 1 all in squared. So therefore, to integrate this, let us say let u to be equals to x plus 1. So therefore, if I derive u, I will have du over dx is equals to, when I differentiate x, I'll get what? 1. Then when I differentiate 1, I'll get 0. So that means du is equals to dx. Du over dx is equals to 1. So therefore, if I make dx the subject of the formula, so therefore that means I'll have du equals to dx. So having something like this, we can also say, if we make x the subject of the formula, we can also say x is equals to u minus 1. So therefore, let's go back to our original equation. Our original equation said our f at x, our integral x over x plus 1 all in squared dx. So now, because of I'm using U-substitution, so that means I should have the integral of u instead of the integral of x. So that means I'll have to where I will say an integral, where I see x, I'll put u minus 1 over, where I see x plus 1, I'll put u, so I'll have u squared. So where I have dx, I'll put du, because now I'm integrating using u. So therefore, now to integrate this, because of I'm having a common denominator, so I can say an integral u over u squared minus 1 over u squared. So therefore, this will be equals to an integral 1 over u minus 1, or I can write this as u to the power negative 2. Why? I took this and I brought it here. So therefore, I'll have 1 over u minus u to the power negative 2. So therefore, I can give each function an integral and say an integral 1 over u minus an integral u to the power negative 2. So to integrate this, I can say what is the derivative of u? The derivative of u is 1. So it follows the rule that says an integral f prime x over f at x, when integrated, it should give you ln f at x plus c. So therefore, here that means I'll have ln u. So when I integrate this, I'll say minus u and negative 2 plus 1 over a negative 2 plus 1 plus c. So our final answer will be equals to ln u minus, so let's see, a minus multiplied by a minus, this will be a negative 1. So a minus multiplied by a negative, it should be a positive. So that means I'll have, so that means I'll have 1 over u plus c. So therefore, our final answer is ln, what is u? We said u is x plus 1 plus 1 over x plus 1 plus c. So this will be our final answer. So now, let's look at example number 2. So saying example 2, saying that we are having an integral x plus 2. sine x squared plus 4x minus 6 dx. So we need to solve this using U-substitution. First, we need to say let u to be equals to x squared plus 4x minus 6. So the derivative of u du in terms of x is equals to, when I derive x squared, I'll have 2x. When I derive 4x, I'll have plus 4. Then this is 0. So therefore, making dx the subject of the formula. So that means I'll have dx is equals to, du over 2x plus 4. So now let's go back to our integral and substitute u. So now I would say an integral. So now I don't want to be left with x. So let's say here I put my x plus 2 sine. So now instead of putting this back, I'll put what? U. So I'll have sine u. Where I have the x, I'll put du over 2x plus 4. So now, because of I want to be left with du, with u only, so I'll say an integral x plus 2 sine u multiply by du over, if here I have a common factor of 2, so that means I'll say 2x plus 2. And if I say that, that means this will cancel this. So if they cancel, so that means now I'll be left with an integral sine u multiplied by du over 2. So therefore, if I'm having something like this, then I can integrate. But before I integrate, how about I take 1 over 2 outside my integral sign? Then I'll be left with sine u du. So therefore, what is the integral of sine? The integral of sine, let's say 1 over 2 multiplied by a negative cos. Cos, the integral of sine is a negative cos u. So if I'm having like this, if I'm having something like this, then I can substitute and say my final answer is 1 over, it's a negative 1 over 2 cos. So where I see u, I will substitute x squared plus 4x minus 6 plus c. So this will be our final answer. I thank you.